Okay, we're in section 136. Very typical, contents to get through. This is going to be tough, particularly if you have not seen trig before. And a lot of students haven't. Don't worry about it. If you haven't seen it, just don't worry about it. You'll take it after you finish algebra. All right? But anyway, I will say that I think a lot of people have seen trig before. But if you haven't, don't worry about it. It's not that important at this stage. You haven't taken trig yet. You'll get there. All right? Anyway, my name is Ron Bannon. It's a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, which dates back to 1904. This document is being prepared for the prison mathematics project participants. I realize other people may be watching these videos, and if they are, for example, students and teachers may be interested in getting a copy of this document. It's not published yet, but if you want to, you can just simply say, I'm interested, tell me how I can get it. I'll keep you updated. Just reach out to me in that email address. That's B as in boy, the @ symbol, nnon.us. So I'm going to say that we spent a lot of time in these, solving cubic equations and, getting into the form we like and then using a formula. It's only got quadratic formula. And it's a derived quadratic cubic formula. And we went through that, all right? It's not easy. All right, so what I'm going to claim over here, they're introducing a method, solution of the cubic equation by trigonometry. And again, when we have it in Cardan's form, all right? So, I'll summarize the method for you because I realize a lot of times when you're reading Wells's work, you might say, gee, sometimes he's really short-winded, sometimes he's long-winded. He will go through an example. But my goal over here is just to, go through an example with you, all right? But as I do that, my claim is I want to summarize the method for you, all right? I want to summarize it. So let me make sure that we know what we're doing over here. I'm going to get this form over here. Sometimes I make a substitution to get that form. If it's not in the form, I got to get it in that form. We have ways of doing that. We identify the A and the B in the problem. We're going to let Z equals this over here. Yep, it's going to be work. And then we're going to say the roots are these three things over here. You're going to see there's a relationship between trig and solving equations. All right, and that comes when you study trig. There's all kinds of things, right? And there's really neat things you can do with trig to solve polynomials, all right? But right now, what I'm going to claim is we want to follow this method over here. So I want to go through this problem over here, and I want to just simply go through the steps. So the first step, number one, is to identify the A and the B in the problem, all right? So I'll write this down over here. What's the A looking at it? Well, let's write this down. It's going to be x cubed minus 4x minus 2 equals 0. So I clearly, just looking at this, the A is going to be 4. And what's the B going to be? The B is going to be 2. So I did that. It's the first thing I do. What's the next thing I do? Let Z equal. I'll write this down. The arc cosine. And again, this could be a nightmare. I mean, really, especially if you don't know anything about trigonometry, what is that function? What's B? B is 2. So it's 2 over 2. It's the root. 27. We'll figure that out later. A cubed. Well, let's see. That's 4 times 4. That's 16 times 4. That's 64, right? Let's make sure I didn't do any mistakes there. Let's keep writing this down. Z equals arc cosine. And what do you get there? You would get 2 divided by 2 is 1, right? And the square root of 27 is going to be 3 root 3. And the square root of 64 is going to be 8. Let's see if I did that right. 27, 3 root 3s. Yep, I got it. I got that. All right, let's go to the next thing. I got to get the roots down now. Now, someone says, could I use a calculator to do that? I'm not opposed to it. All right, what I want to do, though, is I would say that I want to do what they're asking me to do, and it may require the use of a calculator. All right? Now someone says, I don't have a calculator, or I need a computer. I'll talk about that later. But on a calculator, the arc cosine function looks like this. Now someone says, what's that minus 1 over there? It's read as inverse cosine. All right? So you would type in this function over here, 3 star the square root of 3.0. Someone says, why use a decimal point? Calculators absolutely demand it nowadays. Otherwise, you're not going to do the arithmetic. They'll think you're talking exact numbers with them, and they won't do the arithmetic. Divide by 8. You can put 8.0 if you want. And then you can get an approximate number over here. Now, I'm going to tell you on a calculator, I know this is new for you, right? There's modes. You want to be what's called the Radian Mode. But this will return a number. And what is that number going to be? Z. What you need to do is reuse that number over and over again. And then you're going to plug it in on your calculator. What are you going to plug in? You're going to plug in this over here. Let me tell you what you're plugging in. 2, the square root function. It usually comes in parentheses. What's the A? The A is 4. You're going to be dividing that by 3. Let me repeat this. If you're using a calculator, you need to put a decimal point somewhere. All right? And then what are you going to do? Star. You're going to hit the cosine button. And now you want to have this number. My suggestion, since this number is going to be reused over and over again, store it. S-T-O-R-E. Store it in a variable Z. That's all you have to do. And just hit the return button. You should be getting these numbers over here. And again, I am using a calculator. All right? It's tough, though. I realize a lot of students, if you're not at this level, you should avoid this section because you don't know enough trigonometry to do it. You don't know what arc cosine is, you don't know what cosine is, you can avoid this section. Right? It's really not a part of traditional algebra unless, of course, the trig is taught along with it. And the book doesn't have any trig, so I can't say it should be part of the book. All right? I guess he's assuming that maybe the students who are taking this class in Wells' era will also take simultaneously a class in trigonometry, which could be done, by the way. Although there's some overlap between the two courses, you know, there could be done simultaneously or in sequence. Usually the sequence is algebra, then trig, right? But you could do algebra and trig, and a lot of schools now, they actually do that. They do algebra and trig at the same time. All right, but then you get those numbers over there. I do want to point out, you see approximates over here. What I mean by that, if you look at these numbers over here, 2.21's right there. This is minus 1.6, or about right over there. And this is about minus 0.5, right about there. This is not a bad idea. Also, you get the y-intercept, which is 2, minus 2, I mean. You can get that pretty quickly from this over here. All right? Now, let me see what this one over here says. Is that the same question? No, it's different. All right, it's different. All right, so someone says, oh, it's different. Do I have to do the same thing? You do. All right? Now, certainly, they're giving you what appears to be 3 roots. So what do you do over here? You're identifying the A and the B. You're doing the cosine business again. You got to get the Z, things like that. Let me make sure I wrote things down for you. You know what? I hope you can identify, looking at this, that the A is 4 and the B is minus 2. Let's just go over this, all right? And what I mean by that, I want to, make sure you know what you need to do. You need to do the Z equals arc cosine. I'll write that down for you. This is really important. And I'll tell you where this thing is coming over here, by the way. And what's the formula going to be? B over 2, square root 27 over A cubed. All right? And let's see if we can do that. All right? And I think in my notes I might have made a mistake somewhere. Anyway, let me go through it. I have to go through it. So let's see. What's B? B is minus 2, right? So what are you going to get? Z is arc cosine minus 2 over 2, the square root of, let's see, what would you get there? 27. What's A cubed? 64. So you're getting over here arc cosine of minus 3 root 3s over 4. This is a mistake. It happens when I type things up, by the way. I'll correct this, though. You're not going to see it in your version of the notes, by the way. All right? Now, again, my recommendation is to use a calculator to do that. And this is what the z is. And then you just plug it into the formula, and you'll get these numbers over here. Let me just point out what they got here. And I know they put something different down. Oh, no, they didn't. I'm sorry. Same thing. All right. Okay. For the students using a calculator, though, I want to again recommend you have to be in Radian mode. Again, I'll correct this later. All right. You're in Radian mode. You get these things over here. I wrote down what the z is. The z's over here. I would store it in a calculator. It's not bad to do. This is also certainly related to the other one as well. All right. So it's not bad. You can do that. Now, someone says, could I use another method to do that? Of course you can. And you may want to consider that, to go back to the other prior section and say, you know what, I don't like this method. I want to do another method. And you could certainly do that. It's in that Cardan's form. You could use that method that we did with the Cardan form. You could do that, not a problem. All right? So I realize it's a tough section for a lot of students. Why is that? It's got trig in it. You may not be familiar with the trigs. Here's the deal. If you are, and you're capable of using that calculator, I recommend to go through this over here. Again, summary is given to you. The summary is given to you. I'm just looking at it, make sure I'm writing this thing down, and you could do that. It's actually a pretty compact thing. And I will say this, it's not a bad method if you're a computer, if you can compute, all right? But this is an alternative method. You have other methods that we just discussed in other prior sections, right? Do these over here, looking at it. Again, I'm looking at, you're going to get 3 roots over here. Do we give you the 3 roots? Of course we do. Do we go through the method? Of course we do. All right? So this one over here, let's look at it. I'm seeing the 3 roots. What are you doing over here? I go through the steps, and I give you the 3 roots. This one's not in proper form, by the way. All right, so what does that mean? You got to put it in proper form. How do you do that? You got to make a substitution first. What's that substitution going to be? X equals y minus the P1, which is 6, over 3. So the substitution can be x equals y minus 2. All right, you got to do that. All right, if you don't do that, you're not going to get the form they want, and that's the form they want. All right, why is that? It depends on it. All right, it depends on it. So once you get that form, you can certainly identify the a to be 13 and the b to be minus 17. All right, let's keep moving. And I got that written over here. Computations, again, you're allowed to use calculators, and I'm just using the formulas to get these things over here. Right, that's all I'm doing. The problem for a lot of students, though, they don't realize that we're actually solving for y in this case over here, because the equation that we're looking at is this one over here. And then I got to go back to the x. How do you do that? You have to subtract 2 from each y. You have to subtract 2 from each y, and you get these things over here. All right? So make sure you do that. Another problem where I have to make a substitution. What's the substitution going to be? X equals y minus the minus 3, which is plus 3 over 3. So the substitution can be x equals y plus 1. All right? And that should be mentioned somewhere. Yep, right over here. Make a substitution in, and you get this form over here. And then just identify the a and the b, do the formula. And again, if you use a calculator, that's great. If not, don't worry about it. And again, that's the y's. To get back the x, what you have to do is add 1 each time. So you're adding 1 to those numbers. And that's really pretty easy to do, including if you're just doing it on a calculator. All right, Sage. Again, the people coding Sage, sorry about that. The people that code Sage certainly know their math. All right, they know math, not at this basic level, but they know all these kind of algorithms. They might have to look it up. I'm not saying they remember everything. They might have to look it up. But to code something, you would need to know some basic structure of algebra. Beyond the basic structure, though, there's a lot of like nuances that you may not appreciate until you study it in depth, like in Wells' cases here. This stuff is no longer covered, at least my understanding is no longer covered in most algebra classes that I'm aware of, all right? So, again, what's Sage? It's a computer algebra system. It's open source, which means it's free to download. You have to pay for it. That's the website. You can download the software or use the interactive web-based application. And again, what am I doing over here? I'm actually just using Sage to do computations, right? I do want to point out, looking at this, I'm going to point this out to you. I do make a store. Remember I said store the Z? You notice I'm storing A and B, and I write down the function, yada, yada, yada. You may want to study that, all right? Now, granted, there may be things over here you're not aware of. I want to point out that .n notation. That's very Python-like. What's that doing? It's approximating. So if you put down, pi, what's pi stand for? It's pi. This would approximate pi for me, right? 3.14. But here's the deal. You can give it arguments and get a really precise thing, but I'm not too worried about being too precise. I'm just going to take the default approximation for it. And the bottom line is, I go through evaluating these things over here to make sure things are fitting as I expect. In other words, that x1, x2, and x3 actually do produce a 0. So I'm going to say x1 within the precision of the machine did give me 0. But x2 did not really give me a 0. What it gave me a really small positive number. This number over here is very close to 0, though. This number over here, again, is not 0. It's very close to 0. I also want to point out over here, although they're saying this is 0, this is still close to 0. And why is that? They're using a decimal point. They're saying it's close to 0. They're not saying it's 0, by the way. All right? So here's the deal. I'm really not that interested in using Sage. However, it's not a bad idea to try. What am I interested in? If you see any troubles in my notes, what are you going to do? You're going to reach out to me. And you're going to let me know. You're going to tell me you're doing exercise 136.3, problem number 2, and you believe there's a problem. You tell me what the problem is, I'll look at it, and if there's a problem, I'll not only give you credit, I'll make a correction. Thank you for paying attention.